Hi, I'm FIFO, and today we're going to continue our series on the classic wrapper. In this one, we are going to talk about the enforced wrapper, which is an approach aiming at asset issuers to extend the capabilities of classic assets and enforce special rules for their assets. So let's start by covering the use case, what it does, and then we'll dive into the code base and also an interactive demo that you can play with. So let's do this. Alright, so let's start by explaining what this use case does. If you've seen the other series we had on regulated assets, you'll notice that this is a similar use case, but this time it's been leveraged from a pure sorbent token to the wrapper approach. So in this way, we are going to make sure that classic assets can also benefit from those specific rules and those specific behaviors. So if you remember the previous video, what we need to do in this use case is that we need to ensure that the classic asset and the SAC are customized in a specific way. Then we need to provide two extra smart contracts to act as the wrapper, a default implementation for enforced wrappers, and a second smart contract which is fully customized with the special rules we want to apply to our asset. So in this case, we are going with the probation use case. In this use case, what we're doing is, to start off, we're going to configure the classic asset to enable both flags that we mentioned in the past. We are going to enable authorization required, so any account that wants to use our asset needs to be authorized in order to receive or send tokens. We are going to also enable authorization revocable, which means that the issuer or the admin of the token can add or remove authorization to these accounts, telling them that they can or cannot operate with the asset. This is going to be used to programmatically control how they can interact with the asset. Then, as a consequence, my asset cannot be accessed by default. People won't be able to just run native transactions and expect the transaction to go through. This will fail. So why are they doing that? To combine with the other characteristics. So for the SAC, because of the flags, it won't be accessed by default, so users cannot run transactions through this contract directly. And we are setting the admin for the asset as the enforcer, as the enforced wrapper. This means that our wrapper is going to be the admin of the asset and will be controlling the approval of the accounts programmatically. So our wrapper, it can be accessed, and it should. It's going to be the main entry point for the asset, the only way for accounts to interact with this asset whenever it's active. It's going to trigger the probation contract to review the transfers. So in this case, we're only using transfer functions, but in your use case, you could do whichever functions you want to expose from the asset. So we are going to review these transactions through the probation contract, and if they're okay, they're going to go through. And then the wrapper will add and remove the approval to the accounts programmatically to make sure that these transactions can be executed. And on the right, we have the last contract, the probation, which is the asset controller contract. And this is the contract that brings our special rules into the table. So it cannot be accessed directly. It can only be accessed through the wrapper. This is to ensure that no one goes directly into it and messes up with the stats or the states of the rules. And it also ensures that transactions are abiding by the rules, and in case they're not, it is going to throw an error and invalidate the transaction. So let's dive into the specifics of how this use case was designed. The idea here is that we are going to orchestrate the integration between these three contracts to apply the special rules that we're looking for our asset. So if the penguin here on the left wants to make a transfer to our friendly fox, he is going to trigger the transfer through the enforced wrapper. So he's going to ask for the transfer normally as he would with any other asset, but instead of sending this transfer through the classic asset or the SAC, this is going through the wrapper. The wrapper is going to redirect this transfer to the probation contract and ask it to review the transfer. So that's where the contract will apply its special rules. What are these rules? These are arbitrary rules just to exemplify the kind of controls and granularity you can bring to each use case, and it's not what we expect in a real use case. In a real use case, this could be tied to a KYC, making sure that certain rules happen whenever someone is not yet verified, so they have certain limits being applied to their accounts. Or it could also be tied to specific regulation rules in your region or for your asset. So here, what is going on? When a transfer comes, the probation is going to use these attributes that we defined upon initialization to apply its rules. It has a probation period, a quota allocation period, inflow and outflow quotas. So what are these? Whenever someone interacts with the asset for the first time, they enter the probation period. And if we define the probation period that lasts for 1 month, every user will then be in probation for 1 month starting from the moment they first interact with the asset. So during this period, the other rules will be applied. Once this period is over, then whenever they try to do a transaction or they're going to receive some funds through the transaction, it will just verify that the probation has ended already and will let it go through. So during the probation period, they are going to have inflow and outflow quotas. These quotas define how much they can receive or send for the token within a certain time span. So if the Penguin is sending 10 units to the Fox, it's going to allocate 10 units of outflow quota of the Penguin because it's the quota for sending money, and it's going to allocate 10 points of the inflow quota for the Fox, which is the incoming quota for the asset. And it is going to allocate the quota through the quota allocation period. So if we say that the quota allocation period is 1 day, when the Penguin sends the transaction to the Fox, it is going to allocate 10 outflow quota for 24 hours of the Penguin and 10 inflow quota of the Fox for 24 hours. If 1 hour later we run another transaction sending another 10 tokens, it is going again to allocate more 10 outflow quotas of the Penguin and 10 inflow quotas of the Fox for the next 24 hours. So 24 hours after the first transaction, the 10 quota will be released, and 1 hour later, the other 10 quota will be released again for the second transaction. So transactions are tracked separately. And if the contract identifies that someone is reaching the limit, it is going to hold the transaction and make it fail so that it cannot be executed. And once the period ends, or if the asset issuer decides that someone has done KYC or something like that and they want to approve the account, they can manually approve the trust line of these accounts and they won't have to go through the probation anymore. And in the same way, if they want to reinstate the probation for an account, they can do that by revoking the authorization and resetting the probation for those accounts. So that's just one way of exemplifying the kind of granularity an asset issuer can bring into the table. So once the user had its transaction reviewed by the probation will track the stats and the quotas and allocate everything, and once it sees okay, it's good to go, it will pass the transaction back to the wrapper, and that's when the wrapper is going to make sure the transaction happens. The way it does that is through those 3 steps that we mentioned before. It will first set the accounts as authorized, so it will invoke the SAC, and if you remember, the enforcer, the wrapper is the admin of the token, so it has the rights to set authorizations for accounts. So it is going to authorize both accounts, then it's going to trigger the transfer, and then it's going to trigger the set authorize again to revoke the authorization. This way, it encompasses all 3 steps into one transaction and make sure that they happen in an atomic way. So the user is only able to perform the transfer through this transaction. Once the transaction is over, the funds will be sent, but the authorization will have been revoked again, so they cannot interact outside of the wrapper. And that's the way we enforce the wrapper as the only way to interact with the asset, as we want to keep it constrained. So that's the general overview, that's the general approach that we're trying with this use case. So let's have a look on how it would feel from the user perspective. Let's go through the interactive demo and let's play around with it. Alright, so I'm here on my website. I'll leave the link in the description so you can play with this demo as well. And here we have the demo for the wrapper for the probation period. So we'll have these 4 steps at the beginning to configure everything from scratch. And once everything's configured, we'll be able to interact with this asset as the end users and see how these rules play out. So we'll start by generating the admin account, and here you can choose how you want to interact with this demo. You can start by generating a new account automatically and let the demo run the account for you, or if you want to use your Freighter account, you can use this option, and then every time the admin needs to authorize something, it will trigger a signature through your Freighter account. So here, to go faster, I'll just select the generate new account and I'll let the application manage the admin account for me. So I'll click in here and it will generate the account for me. It's going to initialize with FriendBot, and this is using testnet. So everything is actually being executed in the Stellar testnet. All right, we have created our admin account. So now let's define our asset. So let's give it a name. I'll call US dollar FIFO, and I'll call USDF for US dollar FIFO. And here you can see we can select if the interface or the wrapper, if it's mandatory or not. So in this use case, it must be mandatory, it must be enforced because of the way we configure these rules. So we'll keep it as mandatory and we click here to create the asset. What it's going to do is, it is going to generate a native asset with the details that I just specified. It is going to wrap this asset into an SAC. It's going to deploy the standard asset contract for it. And then it's going to set the flags to make these two inaccessible by the end users unless they have authorized accounts. So let's go ahead and click in create asset. And it's going to execute these steps for me. It's first updating the control flags and making the interface mandatory, and you see what is going on as the demo is moving through these steps. All right, our asset was created. Now we are going to define the rules for our asset. So this is the probation that we mentioned before. For the probation, let's define the probation period, and here we're using seconds, so you can look down below at the actual units that are being considered, the conversion, so it's easier for you to understand. And the reason why we're inputting these in seconds is because in the code we define those in seconds. So that's to keep the mindset of the developer building applications like this. So let's set a probation period of 10 minutes just so we can exemplify and see these playing around through time. You could set any period like, if you want to put days, months, or years, go ahead, play with it. For now, we'll set a probation period of 10 minutes just so we can see it playing around as we are interacting with it. And let's say that our quota time limit is something like 60 seconds, so 1 minute, maybe a little bit longer. Let's put 5 minutes, 300 seconds. Okay, so whenever someone interacts with the asset, they will enter probation, and the probation will last for 10 minutes. During these 10 minutes, they will have limits applied to their transactions. So every transaction will allocate quota for the period of 5 minutes each. And the quota they will allocate will define in here. So let's say we'll have 100 units of inflow quota and 150 units as outflow quota. So at any given 5 minutes interval, a user can at maximum receive 100 tokens and send 150 tokens. So once I click here, the demo is going to deploy the contracts, initialize those with the custom rules, make the configurations that I just mentioned, and prepare everything so we can play with this demonstration. So let's go ahead. Now it's going to do all the steps that I mentioned to configure these contracts. All right, fast forward, it just finished configuring everything. Now you're looking at a lot of stuff in the screen. So what do you have in here in this demo? On the top, you have this section in which you can select users to interact with your application and you can generate new users. Here below, you have the section to see the user you have selected and do actions with these users. And on the right, you have the history of every transaction executed in the demo. On the top, you can also see further information. You can click here to see the asset details of each contract. Here you can see information about the classic asset, information about the Stellar asset contract. You can see information about the wrapper interface, and information about the asset controller. And if you want to, you can click here to see in Explorer, and you go to Stellar Expert, and you'll be able to see these assets in the Explorer with the transactions and characteristics and how they appear in the blockchain once they are interacting with the broader ecosystem. So here you can see the USDF that I just created in the Stellar Explorer and the transaction that was executed already. So let me go back here and let me access the other one. Here we have an example of a Tombow file, a fictitious company that would be the issuer of this asset. And here we exemplify how we would add information about this asset in our Tombow file and how we could be providing upfront information for the applications about our contract. We could be saying, hey, this is the idea of our interface, and we expect applications to use this interface to interact with our asset. So builders in the ecosystem could fetch this information from the Tombow file, know what is the interface, interact with the interface to gather the metadata and know how it works, and then provide a seamless experience to the end user. Now let's play around with the users. First, let's click here and create more users. By default, you start with the admin. So it's the account that controls the asset, controls the rules. And you notice the admin doesn't have a probation period. It doesn't have an inflow quota or outflow quota. So if you look down below, you see that the admin has infinite balance because he can just mint new units for the asset whenever he wants. He's not in probation. He won't be in probation because he just controls the asset, so the rules don't apply to them. And he can make certain actions here to interact with the asset. He can send payments to other users. You can come here and select the other users. He can authorize and deauthorize accounts, so you can play around with that. And he can reset the limits to accounts. So he can reset the probation or reset the quotas. So let's start with the first user. Here we have Jack Miller. The users have a similar interface, but now you can see the balance. We started by minting 10,000 units for the user, so you can play around with those. He's not in probation yet because he haven't done a transfer or received a transfer from another user, and he can make payments to other users. Let's go ahead and create another user to make them interact between themselves. On the right side, you can look at all transactions that have happened since the beginning of the use case. So you can go through these transactions and see how they played around. You can click here to see those in the Explorer and really dig through the use case and understand how these play around through time. So second user was created, Amelia Johnson, and now let's make them interact with each other. Once we do the first transaction between one user and the other, both of them will enter probation because both of them will be interacting in different ways. So let's start by sending to Amelia 50 tokens. I'm sending from Jack Miller, so both end users, both abide by the rules. This is being sent through the wrapper. So that means the user account was programmatically approved. There you go, updated information. What are you seeing on the screen? Here you see the balance. He sent 50 tokens, and here you see that he didn't use any inflow quota, but he used 33% of his outflow quota. So out of those 150, he already allocated 50. And if you go down below, you notice this section in which you can see each transaction allocation in action and when they expired. So for the next 4.5 minutes, these 50 tokens will be allocated. Let's do another transaction, send another payment for 15 tokens, again from Jack to Amelia. And what you see is that we are going to add more to the quota. He's going to use more of his outflow quota. And in the quota allocation, there you go. You saw we just allocated 15 more. And if we go here, we can see both transactions separate, each one with their expiration time. So in 4 minutes, we're going to release those 50 units of quota that were allocated. And in 4.7 minutes, we're going to release the other 15 quota allocated. If we go to Amelia, we should see the same thing, but in opposite, because she allocated inflow quota. So if you go down below, you see the same transactions and the same quota being allocated individually. Now let's make a payment from Amelia to Jack. Let's send 60 tokens from Amelia to Jack. And now we should see the same thing happening in the opposite way. She's going to allocate some outflow quota, and there you go, 40%, and we should be able to see it here. Now we have 3 separate transactions being tracked with the allocated quota, and this is all being tracked by the asset controller, by the probation contract. So if we look in here, we see the total probation time. Here you see that her probation ends in a few minutes. We define that's 10 minutes. So there's still 8 minutes to go for both users. If we create another user right now that never interacted with the asset, this user won't be in probation yet. So we can trigger the start of their probation by doing a first transaction with this user. So let's wait a while for it to be created, and let's send a transaction from Amelia to this new user. Now we just created Evelyn, so let's go through Amelia, send a transfer to Evelyn of, let's say, 23 tokens. So I'll send 23 US dollar FIFOs, and once this is done, Amelia will enter her probation period. So it's going for a while. There you go. We can see the transaction was updated here in the history tree, and there you go. Her probation period just started. It's different from the other ones because her probation period just started right now, and that's her quota. So let's try and send more than the quota allow. So Amelia has less than the total quota for outflow. She used already 83. Let's say that Amelia wants to send 120 tokens to Evelyn, but she can't. What is going to happen? Our transaction failed. So why did the transaction fail? Because the contract analyzed that this would overflow her quota and didn't allow the transaction to go through. And the same thing can happen in the opposite way. If Evelyn wants to send, and here let's notice something. Amelia has an inflow quota of 65 used already, but Evelyn can send 150 because she didn't use her outflow quota. But if she tries to send 140 to Amelia, it will fail because of Amelia inflow code. So both users are being tracked and observed by the contract to decide if the transaction should go through or not. Now let's go ahead and play with admin functionalities. Let's say we want to reset the quota allocated for Evelyn. So Evelyn has 23 inflow quota allocated. It's going to take 3 minutes to be released. So let's go as the admin and manually reset that. So the admin, as someone that has the rights to control the contracts directly, is going to select Evelyn and say he wants to reset just the quotas. So just those individual quotas. What is going to happen? You see that Evelyn inflow quota will be reset to 0. There you go, it updated and it went back to 0. So if we look in here, she doesn't even have those quota anymore. So all her quota was reset, but still she's in probation. Let's say we wanna restart her probation. The admin can do that. So the admin can come here, select Evelyn, and this time select to reset probation. So let's reset the probation and quota. And once this is done, we should see this go back to 10 minutes. It's running. Here it was just approved, updated, and there you go, 9 minutes. So he just reset Evelyn's probation. Now, some time have passed. I just jumped into the future, I did a bunch of tests, and now you can see that no user is in probation anymore. The time period has ended. So since they're not in probation anymore, we can simply send as much as we like, no matter the rules of the asset. Let's just recap the rules. The rules are, for 10 minutes, they would have an inflow limit of 100 and an outflow limit of 150. So no transaction higher than 150 should go through. But let's do it. Let's select Amelia and send from Jack, let's say 5,000 tokens. 5,000 tokens is way more than the quota. But since the probation period is over, we should see it go through. Let's wait for a second. There you go. The transaction went through and we can see that no probation is being applied. Now let's go back as the admin and let's update the authorization for Jack and let's deauthorize Jack's account. So we are going to remove the trust line from Jack's account, and right after that we are going to reset the probation, because even with the trust line removed, we still need to reset the probation that he went through. So we're going to reset the period. So let's select Jack and say that we are going to reset both probation and quotas. So let's just wait a while. This transaction is going to be executed right now. We can see in the tree once it's done. And there you go. So now Jack should be again in probation. let's select Jack from the list. We can already see the probation period and the inflow and outflow quota. And there you go, he's again in probation. So if he sends Emilia 150, he should right away allocate all of his outflow quota. And right after that, he won't be able to send any tokens to anyone anymore. So he's in the probation, he has a full quota. Let's try and send one more token to Emilia. And no matter how much Emilia is, and no matter that Emilia is already out of probation, it's Jack's outflow quota that isn't allowing this transaction to go through. So it's tracked by user to make sure that no other user can go through the rules if the admin doesn't want to. So now let's go ahead and authorize Jack's account and step through this. So let me go ahead and select the admin. Let me select Jack. Oh, sorry, let's select authorize Jack and authorize the account. So let's wait a while. We are going to see the transaction being executed in here. There you go. It was already executed and you can see the Jack's account was already authorized. Clicking here on the Jack's account and seeing it, we can see that it has the balance, but it's not in probation. So let's go ahead and select Emilia and send 1,000 tokens. And we should be able to do that, and we shouldn't see the allocated quota down below. So let's wait a while. There you go. It was just sent to Emilia, and that's it. So now if you look here, no user is in probation, no user is under the rules. So go ahead, play with this interactive demo and see how these rules can play over time and how the use case behaves with different sets, with different parameters, and how this classic wrapper can be used by asset issuers to enforce specific behavior. I also recommend that you go through the tree of the transactions in here so you can see the whole history of how everything that you've done happened over time, and you can see those in the Explorer. You can see each individual transaction and you can see the description to understand what was going on in each one of these transactions. Now, let's dive a little bit into the code. All right, we're back. So let me show you a little bit of the repository that has all of the source code for this contract and a way for you to play around with this implementation. So first, in the repository, you see two main directories. You have a contracts directory for all the Soroban implementation and smart contracts, and you have a playground folder that has a project with integration in JavaScript and some tests that you can run to execute these contracts in testnet, and you can have an example on how to build these use cases and how to integrate into your application. So let's start with the contracts. For this use case that we just showed, we have two contracts that we're using here. The classic asset wrapper enforced, which is the enforced version of the wrapper, and we have the probation contract, which is the one that holds those special rules. Let's start with the wrapper. So the wrapper, we can come in here and the entry point will be the lib file, and it will add all of the modules that we are using for this contract. So contract is the main one that has the main rule for the contract. Let's go ahead and dive a little bit in here. So what you're going to see from start is that we have a trait that brings specific features for this contract. So this trait has features and functionalities that we don't expect to be standardized. These are the ones that we just implemented for this use case. Now, so here we have an initialize function to initialize the contract parameters. We have a mint function because we wanted to expose the mint functionality through the wrapper. And down below, we have the implementation of the actual interface of the wrapper. So if you click here, you go to a different directory. You see the standard traits directory. This is a package that can be used throughout these contracts and your own projects if you'd like, in which we are playing around with the common implementation. So we have the interface for the enforced wrapper. We also have here an interface for the optional wrapper with what we would expect an implementation of these wrappers to contain. We also have one for the asset controller, as well as some common features and functions that you could be using in your contract implementation. This is just to exemplify how common implementation can be shared across different builders in the ecosystem if we follow a standardized approach. So let's go back to the contract. And here we have that interface being implemented. In order to make it available here, we are importing it through the standard traits, And for that, we just added it as a dependence in the cargo toml. So here we're adding a dependence to standard traits and the path to the directory where it can be found. So here I imported the enforced wrapper trait, and here we are making the implementation of it for the contract of the wrapper interface. So here we are implementing the functions that are defined by that interface. We have the activate wrapper, set admin, set authorized, transfer, and so on. So what are these functions doing? The activate wrapper is a function that is simply setting the wrapper as the admin for the asset. You remember when I mentioned that it should be the ability to programmatically set and remove authorization? So that's why we're doing this. Whenever we activate the wrapper, we are turning it into the admin, and we are also setting its status to active, to true, so that whenever someone checks the metadata, they are going to see that this wrapper is active. In the same way, we have a deactivate wrapper that does the opposite. So both of these functions start by validating that the admin, the issuer, or let's say a consortium of accounts that we want to use as the admins of this contract, these are the ones invoking this contract. So here we have a simple validation to check if the administrator that we have is the one running the transaction. Then we are setting it, the contract, as the admin, or removing this and setting back to the admin, to the original one, and then setting it as active. If we go further down, we have some other helper functions, and most importantly, we have the transfer. And here is where we are implementing the function that is going to be exposed to the end user, the actual transfer. So the way this is being done is that we are wrapping this function with the custom behavior we want. So in here, we are making sure the contract is initialized by a simple check to see if the original parameters that customize this asset, this wrapper, were already stored. We check if it's active, and in case it is, we check if the sender of the transfer has authorized this execution. We gotta be extra safe and make sure that nothing is happening without the user's authorization. So as we move forward, we then invoke our review transfer from the asset controller. So how is that done? Here in the asset controller file, we are importing from the standard traits the interface for the asset controller. So this interface, the only thing it does is to tell that an asset controller, in this case, is going to have a review transfer that is going to receive the exact same parameters as a normal transfer, and it's going to do its magic. We don't know what it's going to do. It doesn't matter for this contract. The only thing that matters in an implementation standpoint is that it's going to receive these parameters, and if anything should fail, it is going to fail. So this way we can implement any sort of custom rules we want by just following this interface. So here we're just saying that our review transfer is going to initialize a client for this asset controller based on this interface and request the transaction to be reviewed. Once it's reviewed, if it moves forward and it means that no rule was broken and it's ready to go through, then we just do the transaction itself. And the way we do it is that we initialize a client for our token, and we do something here that is special because it allows us to make one implementation available for different methods, for different functions. So what I do is we get the transaction we want to run, the transfer, and we store it in a variable, the action that we want to run. So we also get the addresses of the sender and receivers, so the accounts that need to be authorized temporarily, and we pass these to the accounts and the action we want to run to a specific function that executes with temporary authorization. Why are we doing that? This way, we can have different methods from that asset exposed, or at least wrapped, in using the same implementation to temporarily authorize the accounts. And the way this function works is very simple. It will generate an array of temporary authorized addresses. And the reason we do that is because depending on your use case, it's possible that the issuer of the asset has manually authorized the trust line, or there is an account that they want to operate freely and not be subject to the rules. So in this case, we don't need to authorize this account, and we also don't want to revoke the authorization by mistake if the account is already authorized. So what we do is we initiate this array that is empty, and we check both accounts. So we check if these accounts are already authorized. So if they were already authorized, we won't do anything to those. But if they aren't authorized, which means that in order for this transaction to go through, they need authorization, we are going to push them into this array, and then we are going to authorize the account, run the action, and once we finish running our action, which in this case is a transfer, we are going to look into the array and revoke the authorization for the accounts that were temporarily authorized. Once that is done, the transaction should just go through, and that's it. As simple as that, the standard was implemented. We have other helper functions in over here, so I would recommend that you go through the code base and have a look and play around with those, have your own different flavors of this wrapper so you can have a taste of how these could unfold into different use cases. Now let's have a look at the asset controller. So the asset controller we used in this use case is the probation one. So let's click over here and go to the probation one. And if we look at the entry point, we also have a lot of modules. These are separated by responsibility. If we look into contract, that's where we have the main implementation. So again, we start by having a specific trait for this implementation. So here we have the initialize function that is going to initialize the state and the custom rules for the probation that we set in the demo at the very beginning when we said that the probation was going to be 10 minutes long instead of a month or instead of a year. And we also have other functionalities that we created that are specific to this use case. So how to reset the probation and to reset quotas, all of the get functions to fetch data and provide to the application, and so on. And then down below, we have the implementation of the trait. So the asset controller trait that we implemented here, that comes again from the standard traits package. This one just requires one function, which is the review transfer. So the review transfer, it's going to receive the same parameters as a normal transfer, and it's just expect the transaction to either go through or fail. So here we implemented our own custom rule for the review transfer. Here we check if the contract is initialized, we make sure that we are only being invoked by the wrapper, and that's important because we don't want people to directly invoke this contract and fake a transaction. If I didn't have this check right here, I could make direct invocations to this contract, to the review transfer, faking a transfer just to allocate someone's quota. And we don't want that to happen. So here we make sure that we are only going through if this contract is being invoked by the wrapper contract. And the way we do that is simply by requesting the authorization of the wrapper contract. So whenever we're going to make the invocation from the wrapper contract, we authorize this contract to run. And moving forward, what we do here then is basically to check for both accounts, the sender and the receiver, the same steps. We check if they're in probation, and this includes when they're starting probation. In case they are in probation, probation should be applied, so we look at the rules. So if they're the sender, we check for their outflow limit. And in case this goes through, we then record a new transaction, we add this new quota, and then we launch an event that can be consumed by the applications to know that something happened. And we do the same thing to the sender. So it's pretty standard. We're just tracking these intervals, we're calculating what rules should be applied. This is completely customized. If you don't want to use these rules, you can simply build your own rules with your own flavor of control asset and use the same kind of interface and the same kind of standard. So again, I recommend you go through the repository, play around with those. Now, if you want to see those things in action, I recommend you go through the playground. So first, if you access the through the root folder or through any of the contracts folder, you are within a workspace in Soroban. So if you look, we have this cargo toml at the root folder that defines that all contracts are within contracts. So if I run the Stellar CLI to build contracts in the root folder or within those folders, it will compile all of our Soroban contracts. So you can just run Stellar contract build, and you'll have your own version of these contracts built and compiled into WASM files into your repository. And let's show, and they just finished. So if you go here and go to the root folder target, you should be able to navigate through these and find all the contracts in here so that you can use those in your application. Now, once they're deployed, you can come into the playground and see those in action. So let's navigate to playground, classic asset wrapper. And here we are in this node project with some automations that you can run through this make file. So you can have a look at this make file. It has a bunch of commands. You can just invoke make help or make h, and you see all the comments being outputted in here. So let me just close this a little bit. You can see all the comments. So you can deploy the probation contract, you can deploy the enforced wrapper, you can generate the TypeScript bindings for those, so you can use those in TypeScript, and you also have integration tests that run in testnet. So let's go little by little. If you run the make deploy dash probation, it is going to trigger a TypeScript script that is under deploy, upload, and deploy. And what it's going to do is that it's going to read the WASM file that you just compiled, and it's going to generate an account, upload to the network, create a new deploy, and provide you with the WASM hash and also the contract ID. So you can use those in your application. I recommend you do that, and also that you feel free to, oh, sorry, let me go back. I just navigated. I recommend you play around with those, deploy your own versions, and feel free to customize this makefile as well. So here we have variables for these contracts, so feel free to deploy your own ones and add the contract ID to the makefile, and also play around with the comments so that you can have your own tests and your own automations running on here. So I have those deployed already. You can also generate the bindings. So let me go ahead and say let me go the comments again, just so I can copy. So let's say I wanna generate the bindings for the probation. So I'll select here, make generate bindings probation, and run. If you're running these on Windows, normally you're going to get an error. If you run these on Mac OS, you shouldn't get those, but the bindings are generating no matter how. Let me see, no matter what. Here they are within the playground. And if you go there, you should see the probation folder and the bindings in TypeScript. So this is a good way for you to get the TypeScript typings for the payloads and the responses. So you can have also the spec, which is the XDR encoded spec of the contract. This is very useful to integrate with TypeScript. So we've done that already in the past, and we generated our own interfaces. So if you go through the source of the playground on contracts, you should see all of those contracts. So you have here the probation. If you go on constants, you see the enum for all of the methods that you can access. You can see the specs. You have the types here on a types file with all the payloads and responses that you should expect. And you also have this index file with a class for your own probation contract. So you can initialize this class and it will expose all of those methods to invoke or just read from the ledger. And we're using Stellar Plus here to make a very simple integration. So I recommend you go around, play with those, have a look, see how they can be integrated. And if you want to see it in action, you can go to the tests folder and you have integration tests for each use case. So the probation is here, probation.integration.test.ts, and you can run those with Jest. So if you have Jest installed, you can just run. And here we have a small user story of the whole configuration up to the point in which you're using. So you can look into those as a reference, and you can see how you would integrate that in your application and how we did with the web application demo that I just showed. So here, I recommend go around, have a pick, and let me just run to show you how it looks. So I'll select here, make test probation E2E. And once I trigger that, it's going to run with Jest. It's going to run in testnet. So this takes a while, it takes a couple of minutes. So let me get back once it's finished. There we go. We just finished. So it took close to 2.5 minutes, and here you can see the whole output. So the way it's structured and the way we try to tell the story is that it starts before the contract setup. It starts the whole use case, and before the setup, it will wrap the SAC contract into the for the asset, the classic asset. then it will set the revocable and not required flags. You'll be able to see these transactions individually. Then we have the setup phase. In the setup phase, we do the configuration of the rules. So we upload both contracts, the asset controller, the classic wrapper. Then we deploy new instances for each one. So you can see those individually here. If you go through the test case, you should be able to find those. Here, for example, should deploy a new instance of the asset controller. So it's just this execution and the way we verify if we got the contract ID correctly. So you go through the deploys, then it's going to initialize each one of the custom parameters, and then we enter the next phase. Once the contracts are initialized during the setup of 2 users, so we set up 2 users, creating their trust lines, and then the admin mints some units through the wrapper to send to these users, and this reflects in their classic balance. Then afterwards, we run a few tests just to show things moving around and limits being applied. And here, I really recommend that you take this, play with it, break it, customize the rules, generate your own versions of the contract and the interface so that you can see in action how these things could be customized in different ways. I hope you have liked it. This was the first use case. Now, for the next video, we should be tackling a different approach, one that's not enforced, and should be aiming not just at asset issuers, but anyone that wants to provide a different route or a different path to interact with the classic asset. So, see you in the next video.